velocity. First of all, we'll analyze this. What is the orbital speed? Gm by r. The expression for orbital speed, no? G me by r. This is the velocity of satellite here, orbital speed. So what is the stone? It is projected with a relative velocity, that is Vr. Let me write Vr. So there's a stone. So you take this as stone. What is the mass of stone? M. It is having Vr like this in the forward direction. So what is the absolute velocity of stone? So shall we use the formula like this? Velocity of stone, particle, right? Stone, or velocity of particle with respect to satellite is equal to velocity of particle minus velocity of stone minus velocity of satellite here. So what is the velocity of particle? We don't know. Velocity of this is what? Vr. Velocity of satellite is V naught. Particle only. Yeah, fine. Particle. No. What is the velocity Vr? Vr is given by root of let's see what we'll get it. So what is the velocity of particle? Root phi V naught by 2. Okay, fine. This is the velocity of particle. No. Is it greater than V naught? Is it greater than V naught? Yes, it is greater than V naught. If the velocity is greater than V naught, so what should happen? It's going to leave that circular orbit and it's going to describe elliptical orbit. Will I agree? Please just do understand some things what we have discussed here. Just now I discussed, no? That only we have to apply it here. But tell me, when it leaves circular path, so it's going to describe elliptical orbit. Here I'll take the diagram. And it is going to describe an elliptical orbit. Tell me like how that Earth should be. Earth will become one of the foci, and the point where it lives will become perigee or apogee. Will become perigee. Will become I think some rough diagram I'm able to give only this much. So I'm not bothered that satellite. I'll leave that satellite. Satellite will be revolving here. It will be revolving in circular path. That is V naught. Now let's talk about the particle. It is having velocity Vp. This Vp is greater than V naught, no? So what should happen to it? It is going to live with Earth as one of the foci, and this will be perigee. This will become apogee here. So this velocity called V1. This velocity, let it be V2. So this distance, let it be R2. Let this distance be R1. Tell me what is R1? R1 should be R, no? R1 should be R. Calculate the minimum and maximum distance from the Earth's center during subsequent motion of the particle. So we have to calculate this R2. Are you able to understand? So this will become apogee. This will become perigee. Agree this? So what is this? What I should call path of particle. This is what? Path of satellite. Okay, now sir, how to get this? We don't have anybody here except what? Conservation of angular momentum, conservation of mechanical. Between what? Between 0.192. I'm just giving V1 and V2. No, let me write this is 2.2 apogee and there's a 0.1. Right. This. So what is the conservation of linear momentum? Conservation of angular momentum. Mass of particle V1 R1 equal to mass of particle V2 R2. V1 R1 equal to V2 R2, and we know R1 equal to R. So why, sir, now your task question, sir, why R1 equal to R? Already we explained the synthetical idea. No, sir, like still we assumed it. Definitely I need a mathematical proof. Okay, at least one thing we are very sure. What is that? Either, so what happened? Either what happened? The point where I projected particle should be either perigee or apogee. Will I agree? Either perigee or apogee. So let me solve it. I'll solve for R2. If R2 greater than R, then this will be perigee, this will be apogee, that one. So there's the equation 1. Now conservation of mechanical energy minus G mass of earth, mass of particle R1 V1 square minus Gm MP R2 plus, oh, we have space here. Yeah. Solving these two equations will, what are unknown things? But we don't know V1, no? V1 is what? V1 is Vp. We know V1, we know R, V2, R2 are two unknowns, two equations, two unknowns. Solving them will get the required answer. You have to work out. It's like some, anybody R2 value? But what to do? The other things are there, no? So GMER, you can write V0 here. What to replace with GME? This expression for V0, can you take help of this one? V0 is what? Root of GME by R. R is the radius of that particular thing. So therefore now R1 is equal to R and Vp is equal to how much? V1. And Vp value also we know it. So everything, I think that GME, GME, MP will get cancelled. Even GME also get cancelled. So everything will get only R2 in terms of R, solving these two. So you do one thing, from equation 1, write V2 in terms of R2. Keep it there. Then what to do with the GME, that you should replace with this one, V0 R, and we have to solve it. Anybody value? Quadratic equation will come. I think nobody is responding. Let me go for it. GME, so from here, V0 square R. MP anyway got eliminated. What is R1? R1 is R. Then MP get eliminated. V1 is what? VP, and this is equal to root 5 V0 by 2, and this is 2. Minus GME, so this should be equal to V0 square R, this is R2. 1 by 2. V2 square, what you can write it as? V0 R by R2 whole square. Okay, now, so somebody is telling R2 equal to R, quadratic equation 5 by 3. Okay, I'll write it that quadratic equation. Solving this and simplifying everything. So we'll end up with the equation of like 3r2 square 8r0 r2 plus two values are there. No, which one you are going to pick up? R2 should be greater than R1. See, like things are very easier. Huh? You can check it now. R2 must be greater than R1. Should be greater than R. So now you can ask questions, sir, on what basis you can say that this will be apogee. The point will be apogee. Say R2 cannot be equal to R. So what is the only possible? This is only possible where if you pick up this is apogee, this point 2 is apogee, then this should be perigee. So therefore this distance will be R. So this will be our answer. Huh? So what is the minimum distance? R minimum equal to R1 R. R maximum equal to R2. Sorry, 5R by 3. Fine. So you can do one thing, same problem. You project with a velocity Vr root 5 by 4 plus 1, or you make the velocity of particle less than V naught. In that case, what will happen? This will become apogee. This will become apogee. This will become perigee. So the particle is going to describe like this, the path. Velocity of particle less than V naught. Since the velocity of particle is more than V naught, it will use circular orbit and elliptical orbit with Earth as one of the foci. The point of projection is perigee. If the velocity of particle less than orbital speed, it will use circular orbit and is going to describe it with Earth at one of the foci, and the point of projection will be apogee. Is it okay? If you want, you can try the same thing. You just make the velocity of particle less than V naught and see that your path will be like this. But it must be elliptical only.